Blockchain. I'm sure you've heard the word thrown around a lot, probably connected to things like Bitcoin. But what is it really? It's one of those technologies that gets talked about all the time, but very few people actually understand it. Well, today we're going to change that. We are going to pull back the curtain and demystify this thing once and for all. Okay, so here's how we're going to break it all down. First, we're going to take a quick trip through the history of money, because you really need to see the problem blockchain is trying to solve. Then, we'll look at the brilliant ideas that made it all possible. After that, we'll finally define what a blockchain actually is, explore its core features, its superpowers, really, and then wrap up with how you actually use it. All right, first things first. Before we can get to the solution, we have to understand the problem. And believe me, it's a problem that's been with us for thousands of years. And it all comes down to one single, incredibly important idea: trust. Yeah, at the end of the day, it all just boils down to this one simple question. For all of human history, every single form of money we've ever created has been an attempt to answer it. How do we trust that this thing we're holding has value, that it'll still have value tomorrow, and that we can exchange it with someone else fairly? Our attempts to solve this go way, way back. We started with bartering, I'll trade you my chickens for your wheat. Then we moved on to things like cows and tobacco as commodity money. Then came heavy coins, then paper money, which was really just an IOU, and now we have the digital money on our screens. But do you see the pattern here? Every single solution either had a major flaw or, and this is the big one, it relied on a central party, like a king or a bank, that you just had to trust. The core problem was never really solved. So even as we moved into the digital age, that fundamental problem of trust, it was still there. But behind the scenes, something really interesting was happening. A series of incredible ideas from computer science and cryptography were starting to connect, pointing toward a totally new kind of solution. See, this idea didn't just pop out of nowhere. It was built piece by piece by some really brilliant minds. Way back in 1991, two researchers came up with the idea of a secured chain of blocks for timestamping documents. Then, fast forward to 2004, a guy named Hal Finney figured out a way to stop digital money from being spent twice. These were the essential ingredients, and in 2008, a mysterious person or group named Satoshi Nakamoto put all the pieces together in the famous Bitcoin white paper, and boom, we had the first real-world application of blockchain. And look, if you think this is all just some abstract, techie concept, let me tell you a quick story. Back in 2013, an IT worker named James Howells threw away an old hard drive. No big deal, right? Except on that hard drive were some Bitcoins he'd gotten for basically nothing years earlier. Today, that digital cash he threw in the trash would be worth $127 million. That's the kind of insane value this new system could secure. And it also shows you the new kind of responsibility it puts on you, the user. Okay, so now that we've set the stage with all that history, we're finally ready to pull back the curtain and answer the big question. What is a blockchain? Okay, here it is, the textbook definition. And yeah, I know, it sounds super complicated, right? A consensus-based security centralized database. What does that even mean? But I promise you, the core idea is actually way simpler than it sounds. Let's break it down. I want you to think of it like a shared digital notebook, a notebook that everyone on the network has an identical copy of. When you want to add a transaction, you just shout it out to the whole network. All the other people on the network check your transaction to make sure it's legit. Once enough of them agree, it gets bundled with other transactions into a new block. Think of it like a new page in the notebook. That page is then cryptographically sealed to the page before it, and that new page is added to everyone's copy of the notebook. And here's the magic part. Once a page is added, it can never be erased or changed. And this right here, this is the absolute game changer. Think about your bank. They have one central database, one master copy of the ledger. If that gets hacked or their server goes down, the whole system is in trouble. That's a single point of failure. But with a blockchain, it's decentralized. Everyone has a copy of the ledger. So to cheat the system, you'd have to hack thousands of computers all at the same time. It's truly strength in numbers. So this whole decentralized structure, it gives blockchains some pretty amazing properties. I like to call them its superpowers, because they're what allow it to finally solve that age-old problem of trust we talked about. First off, it is incredibly secure and permanent. Because it's immutable, once a transaction is recorded, it's set in stone. No one can go back and secretly change the history. Everything is locked down with super advanced math, or cryptography. And since the ledger is distributed across thousands of computers, there's no single target for an attacker. All of this means that when a transaction is confirmed, it is absolutely final. This structure also makes things unbelievably fair and efficient. You can send value directly to another person without needing a bank or a credit card company in the middle, which saves a ton of time and money. The whole system runs on consensus, which just means everyone has to agree on the rules, so no single person or company is in charge. Oh, and it runs 24/7, all the time. Plus, on public blockchains, everything is completely transparent, so anyone can see the transactions. And when you put it side by side like this, the difference is just wow. A traditional bank transfer has a bunch of middlemen, it can take days, and it costs more because everyone takes a cut. A blockchain transaction is peer-to-peer, potentially much faster, and usually way cheaper. But the biggest shift, you're no longer required to trust a company or an institution. You just have to trust the math and the code. Okay, so that's all the theory, but how do you actually use this thing? Well, to interact with a blockchain, you basically need your own set of digital keys and a place to store them, called the wallet. And there are two main types. A hot wallet is kind of like the regular wallet you carry around. It's a software app on your phone or computer. It's connected to the internet, so it's super convenient for day-to-day stuff, but it's also more vulnerable. On the other hand, a cold wallet is more like a safe deposit box. It's a physical device like a USB stick that's kept completely offline. It's way, way more secure for long-term storage, but not so convenient if you want to make a quick transaction. And that really brings us to the most important takeaway from all of this. The core innovation of blockchain, its true genius, is creating a way for us to trust each other and exchange value without needing a central authority, without a middleman. So the real question this technology leaves us with, the really exciting one, is this. When we no longer need a middleman for our money, our data, or our agreements, what can we build next?